Hey guys, welcome back. We're on our next section of sequences and series. We're actually going to start defining them now. They're going to be broken up a little bit, and these are things that you will see on the ACT. And there's one question that always shows up, and I want to show you how to do that because a lot of kids don't, because they don't really get sequences and series in high school as much. Okay, let me see if I can find my... All right. So today, we're going to be able to look at we're going to be able to find the indicated terms of an arithmetic sequence, and then we're going to be able to find the sums of arithmetic sequence. And we're really going to define what arithmetic sequences are. There are two different types of sequences in series. We've just done a holistic view the past couple times, but there are two types, and we're going to break those two types down. The first one, which is today's lesson, is arithmetic, and then the next one is geometric, which will be next class period. So, the cost of mailing a letter in 2005 gives the sequence 0.37 cents, 0.6 per weight. Oh, it gives this sequence 0.37, 0.60, 0.83, and 1.06. This sequence is called an arithmetic sequence, and this is key right here, because its successive terms differ by the same number. We call this the common difference. For the mail cost, the difference between each number in the sequence is 0.23. Okay? So if it's an arithmetic sequence, it has a common difference between each term. So here we go. Here is term 1, 0.37, term 2, 0.6, 0.3, 0.83, term 4, 1.06. The difference between each one is 0.23. Remember the very first lesson where we did the first difference, the second difference, and the ratios? We tried to see which one was the same on all those. Well, if it's got the same first difference, it's called an arithmetic sequence. Okay? Recall that linear functions have a constant first difference. Notice also that when you graph the ordered pairs of an arithmetic sequence, the points lie on a straight line. Thus, you can think of arithmetic sequences as linear functions with sequential natural numbers as the domain. And that makes sense. When we talked about it having the same first difference, we said it was linear. We talk about it having the same first difference as arithmetic. Okay? Okay. So here's your first example, and this will be what your homework will be like, okay? So we need to first determine if this sequence is arithmetic. So what you need to do is you need to look at each term and then find out the difference between each one of them. Since they have all the same first difference of 6, we can determine that this is arithmetic. This sequence could be arithmetic with a common difference of 6. Okay, so that's your first section, or that's your first type of problem you'll see on your homework. Here's example 1b, the same thing. We're going to determine if it's arithmetic, and if it is arithmetic, we're going to find the common difference. If you look at each one, the difference between each one is different. -3, -6, -9, -12. This sequence is not arithmetic because the first differences are not common. Okay, so the first couple questions on your homework should be pretty easy because all you're telling me is it arithmetic or not? Here's another example. If you look at each one of these and see if it's arithmetic, they have the same first difference. So it is arithmetic with a difference of -0.07. And then there's one with fractions. Okay. If you notice from the previous one, each term in an arithmetic sequence is the sum of the previous term and the common difference. Okay? So if I went back here and looked at this one right here, notice that -4 is this number plus 6. 2 is this number plus 6. 8 is 2 plus 6. 14 is 8 plus 6. That's what that slide right there is telling you. And because we know that, we can come up with the formula for arithmetic sequences, which is really nice. It is a sub n, so whatever term you're trying to find, equaling the previous term plus the difference. That's the recursive rule. You can also develop an explicit rule for an arithmetic sequence. Notice the patterns in these. Each term is the sum of the first term and a multiple of the common difference. This pattern can be generalized into a rule for all arithmetic sequences, which is super important to know and understand, especially for the ACT when you're trying to find a certain term. So here's the rule for you. Here's the general rule for arithmetic sequences. Super, super important. The nth term, am I going too fast? Okay. The nth term of an arithmetic sequence is given by this equation right here. Super important to know, especially for the homework. And let me tell you what this equation is saying. A sub n, meaning whatever term you're trying to find, equals the first term, because of the little 1. So it's the first term plus the term you're trying to find. So if you're trying to find the 50th term, you put 50 there, minus 1 times the difference. Okay? So you need to know the first term, you need to know the term number that you're trying to find, and you need to know the difference. So let's say on the homework, I asked you to find the 12th term of the arithmetic sequence. You might have seen this on the ACT, and you probably were like me and just continued that out until you got to the 12th term. But on the homework, I think it says for you to find the 52nd term. That would take a long time. So from here, we can just plug this into our formula to get our 12th term. So we need to know the first term. What's the first term here? 20. We need to know the number of the term we're trying to find. And what is the number of the term we're trying to find? It's the 12th term. And then we need to know D, which is the common difference. So how can we find the common difference? Well, we just do what we did in the beginning and look at the difference between each term. So the common difference here is negative 6 because it goes down by negative 6. So that's step 1. Find the common difference. Step 2. Evaluate by using the formula. We're going to plug all those numbers we just talked about into our formula here. So the first term, 20, plus our 12th term minus 1 that we're trying to find times the common difference, which is negative 6. You get negative 46. The 12th term of that series, or the sequence, is negative 46. And then if you did this on the ACT and you didn't remember the formula, you would do this down here to see if that would be correct, and it is correct. Find the 11th term of the sequence. Again, you need to know the first term, which here it's negative 3, the common difference, and all that, and then you can plug that into your formula, and you would get your negative 23 term there. So I think I have a few examples in there for you. Did I do this one too in your notes, just so you have it?
Find the 11th term of the sequence.
So there. These are all there for you. If you need help or if you need some time to go back and look at some examples. Let's look at example 3 now. What if I want you to find the missing terms? What if I want you to find missing terms when given the first and the last term? Now let me tell you something. Just because some of these examples aren't going to be on the homework, it doesn't mean it's going to not be on that in-class assignment. So make sure you have your notes. I'll make sure to turn them back so you can do these. So I don't know if I have this specific type of problem on the homework. I know I do on the in-class test, though. Okay, so here is our, here's what we would do here. The first thing you want to do is find your common difference. And in order to find a common difference when you're given a sequence like this, you want to look at your formula there. We know the fifth term is negative 7. So if we know the fifth term is negative 7, we can go ahead and put negative 7 into our formula as our answer and solve for D using algebra. So we know the first term 17, and we know that the fifth term was negative 7. So from there we can use algebra to solve for D, negative 6. And then, if you want to use that, now you have the general difference. You can plug that in to find each term by plugging it into your equation. So to find your second term, you just put 2 into your equation. To find the third term, you put 3 in. To find the fourth term, you put 4 in. So there's another example there for you that you can have, especially when we get to that in-class assignment there. Now, because arithmetic sequences have a common difference, you can use any 2 terms to find the difference. It doesn't have to be successive terms. So I want you to find the common difference, or find the nth term, given 2 terms. So let's say all I tell you is that the 8th term is 85 and the 14th term is 157. Again, we can plug all this into our formula. We have the 14th term equaling the 8th term plus the 14 minus the 8, because those are the 2 terms that we're using. Remember, this is the first term, and we put 1 here. So if we have the 8th term here, we can put an 8 there. And then we would simplify and get D. So there's an example there for you on how to do...
So it doesn't have to be the first term.
Right, it doesn't have to be the first term. But notice, when we use the 8th term instead of the first term, we don't subtract it by 1. We subtracted it by 8 because it's the 8th term. Okay? So just make sure you're looking at that if you have a question like that. For that. So step 2 would be finding A1 using that information that we plugged in there. And then step 3 would write a rule for the sequence and evaluate A5. This is not on your homework today, but it is something that I don't know if I put on the test. Okay. So I don't even think I put another example on there. Okay, so in the last lesson we did, so in lesson 9.2, you wrote and evaluated a series. An arithmetic series is indicated sum of the terms of an arithmetic sequence. Remember what we did that last time. You can derive a general formula for the sum of an arithmetic series by writing the series in forward and reverse order and adding the results. So if I'm asking you to find the sum of an arithmetic series, we can see this here. If we have the first term plus the difference plus the first terms times 2 times the difference, we can get all of our terms and then we can add them all, right? So we've been doing this. This is how we get each term. Now we're going to add all those. That can be a lot of work, especially on the ACT when you only have a minute per problem. So through this proof, we actually have a formula that we can come up with that if we would spend more time in this, we could actually prove. But here is the formula for you. And so we've put it in a nice little chart for you. The sum of the first n terms of an arithmetic series is the product of the number of terms and the average of the first and last term. So let's say I asked you to add up the arithmetic series 2 plus 4 plus 6 plus 8 plus 10. You can either put that into your calculator or you can just use the formula. How many terms do we have there? 5. That's why we put a 5 there. Then you add your first and your second term, or your first and last term. So we're going to add 2 plus 10, and then divide that by 2. When we do that, we got 5 times 6, which is 30. So there's the formula. I'm going to ask you on your homework to evaluate a arithmetic series, and so you would just plug and chug into your formula here. Okay? So I want you to find the indicated sum for the arithmetic series. I want you to find the sum of the first 18 terms, or the 18 terms of this series here. Now, I'm not giving you all of it, right? I'm just giving you a couple of them. So the first thing you want to do is find your common difference. We know the common difference between each one is negative 11. Then you got to find your 18th term, because remember, in our series addition summation formula, we have to know the first term here, which is 13, and the very last term that we want to add, which is the 18th term here. So we need to use the first formula we learned in order to figure out what the 18th term is. And when you look at that, that's 13, because it's the first term, plus 18 minus 1 times the common difference.
Is that a typo on ours? It only has 8 on ours.
Instead of 18?
Yeah.
Yes, that would be a typo that I need to fix then. Where's that at, so I know to fix that for next year? Example 5, yeah.
Yeah, I'm sure.
Where it says find the 18th term?
I think it's one now at the top, though, where it says S sub 8.
Oh, yeah. That should say S sub 18. I need to fix that. Thank you. Thank you. Yeah, let me know, because I probably made a few mistakes on there. So, yeah. So the first thing you want to do is find the common difference, which we did. Now we know the 18th term is negative 174. Now that we know the first term and we know the 18th term, we can plug all of this into our summation formula here. Remember, it is n, which is 18, because that's the number of terms we want to add, times the first term plus the last term divided by 2. So 18 times 13 plus negative 174 divided by 2. Okay? And that is that. These sums are actually partial sums. You cannot find the complete sum of an infinite arithmetic series because the term values increase or decrease indefinitely. So you cannot add infinite ones there. And then the last thing on your homework, I'm going to be asking you to find the sum of the arithmetic series when given it in sigma notation. Okay, so here's what you're going to be doing here. I want you to add the first term all the way through the 15th term. That's what that means there. So if you look at your sigma notation here, that's what these numbers here represent. I want you to add the first term all the way up to the 15th term using that formula there. So the first term all the way up to the 15th term. Okay, so now we just plug this into our formula. What would the first term be? Because we have to know the first term, we have to know the 18th or 15th term, and then we have to know the number of terms. So the first term, plug it into your original formula. 5 plus 2 times 1 for the first term. And then we find our 15th term. We use the formula 5 plus 2 times 15. So now we can go ahead and find the sum. What?
So this one's a lot like that.
I think the sigma notation is a lot easier. That's why they developed it.
Because you don't have to do the others.
Exactly. So now you can plug it into your summation formula, n being 15, the first term plus the 15th term divided by 2. Okay. And you can check always with the graphing calculator. I will show you, well, no, we'll just do that later. Example 5b, find the indicated sum for the arithmetic series. This is just another example, not given in sigma notation. Again, the first thing you want to do is find the common difference, and then you got to find the 16th term. You got to find that last term you want to add up to by using the formula, which is negative 63 there, and then you can put everything into your summation formula and get negative 408 as your answer. Okay, that was it for this lesson. I think it was pretty easy. It's a lot of words. I do have practice problems on there online that I was going to go over, but I forgot that I had all the examples in the notes. So that's your homework. Let me show you what your homework will look like. By the way, your homework's on your notes. Okay, so look here. You're going to first tell me if it's arithmetic or not. Super easy. All you have to do is see if it has the first common ratio. The next thing you're going to do is find the next 3 terms in the sequence. I didn't give you an example about that. However, if you know the common difference, you can just add that common difference to the last term to get your last 3. Super easy. That shouldn't take you more than a couple seconds. Shh. The next one, you want to find your 52nd term by plugging it into your formula. So that's what I want you to do there. And then I want you to evaluate each arithmetic series. That's what we did the last couple problems. There's the ones without the sigma notation, and then there's the one with the sigma notation. Are there any questions on what you're doing? Okay, if you have any questions, please feel free to reach out and ask me. But that's it for today. Enjoy your time doing this. Thanks, guys.